Hello everyone, welcome to this tutorial. My name is Emerson Ahrari. I'm a Google Earth Engine expert. In this tutorial, I'm going to show you how to calculate the dry spell. Here, the dry spell means the number of the days in which precipitation is equal 0 millimeter per day for a couple of days in a row. So as you can see here, in this tutorial, you will learn how to make such kind of table that shows the dry spell, starting date, end date, duration based on days and intensity. So this could be very beneficial for the drought monitoring and precipitation data analysis. So it's very simple and easy to use in the Python programming language. Let's get started. Make a new notebook in Colab environment. This tutorial, same as the other tutorials, I'm going to use Google Earth Engine platform and also Python API programming. So in the first step, we need to call necessary libraries to deal with the Google Earth Engine in the Colab. So start with import EE Earth Engine library, import GEE map as GEE, import Xarray, a specialized library for multidimensional data analysis as XR. So run the first cell and go to the next. In the next step, we need to install XEE, a new library developed by Google, allowing us to actually integrate X-array structure and image collection together. That could be really beneficial for extra analysis on satellite data calling from Google Earth Engine. So now we need to install XEE. Pip install XEE and then import XEE like this. So once the XEE installed successfully without any challenge, as you can see here, in the next step we need to make a connection between Earth Engine and Colab environment through the authentication first and Earth Engine dot initialize the project. So as you can see in the code editor environment, every one of us actually have an account in the Google Earth Engine platform. For example, if you go to the code editor environment, up in the corner upper right here, you can see the account information. If you go to the project info, you can see the associated cloud projects. So now the first argument is the project name or Google project name here. Just copy your own cloud project name and paste it as a string here. The next one is OPT-URL. If you go to the XEE instruction, you can find the address for the OPT URL. So copy and paste it. Let's run the cell. A new message popped up. Click on allow. We are allowing to Colab to connect with Earth Engine platform. So click on continue and continue. Now the connection is made, and in the next step we can identify the region of the interest, make a new cell and try to actually call a user interface to select the region of interest using GEE map. Map equals to from GEE library dot map, call the map with a base map equals to, for example, satellite base map considered here. Print the map. After a few moments, you will have a user interface that allows you to find your region of interest. For example, in this study, I'm gonna select Iran as a case study for the precipitation data analysis because Iran is a four-season country and precipitation varies from one point to another point. Some of the regions experiencing very wet condition or very high precipitation rate per year, and some of the areas actually suffering from a very dry situation. So Let's select your region of interest using the rectangle. However, this tutorial is not limited to only one region. You can use this tutorial for all around the world. The satellite data and the platform, every one of both of them available for for all around the world. So, once the region of interest selected, we need to have the rectangle as a geometry. Make a new variable or ROI equals to, from the map we want to select the feature draw. So draw last feature dot geometry, just like that. The ROI created. Now we have this actually ROI or rectangle as a new variable that we can use that in the next step to select the region of interest without any challenge. The ROI equals, and now for the next step we need to call the satellite data. Make a variable as collection and go to Earth Engine data catalog and find Persian CDR dataset. This is the daily precipitation data available in the Earth Engine platform that is really popular for the PR data analysis. So just copy the collection snippet and paste it here. Filter it to your time bound or time span. For example, I'm gonna study on precipitation data from 2020 to 2022. 2 years considered here. Let's run a cell and then go to a new one. So here we have an image collection. This is an image collection format including different images for different dates. But for dry spell analysis, we need to convert it to a multi-dimensional array structure. Thanks to XEE library, we can easily convert the image collection to array structure. So make a new variable as dataset equals to, from XR or X array structure, enter open the dataset. The open dataset including couple of arguments. The first one is the image collection as an input, and the next one is engine sets to EE, and then coordinate system equals to EPSG 4326. EPSG actually 4326 refers to WGS 84 and is same for all around the world. The next one is our geometry or region of interest. Geometry equals to ROI. This is very helpful to subset your data based on ROI in the first step because highly reduce the speed, highly reduce the actually the volume of data and the speed of processing for the further steps. So, and the scale of input data is 0.27 as the spatial resolution is 27,000 meter. Here we need to convert it to the degree format. So 2007,000 is equals to 0.27 because 1 degree actually equals to 100 kilometer, 0.2 20 kilometer, 0.27 27 kilometer. Let's run the cell, and after a few moments a multi-dimensional array structure created. Let's run the dataset again, and here you will have a multi-dimensional structure. Why multi-dimension? Because we have a dimension for time, longitude, and latitude, and also a variable that shows the variable values changes through the spatial and temporal variation. Here you can actually check it up, to check the data, different characteristic, and different properties easily. In the next step, I'm gonna do a visualization to have a preview about the precipitation pattern in a season in different season in the Earth Engine platform. So now, as you can see, a new cell created and a new variable as seasonal made. So seasonal equals to the dataset brings the dataset calls here, and then through the resample you can convert your data to a quarter actually format. So time, one of the dimension here, we have a dimension as time equals to q. Q here means the quarter. So for each quarter of year or quarter or 3 months of year, we want to get sum for each pixel through the time, sum of the precipitation per season. So let's run a cell and seasonal data created after a few seconds. As you can see, the process is ongoing, and if you had any problem and challenge about the code, you can find the code link below the video on my YouTube channel, and feel free to pick it up and compare your code with mine. And if problem still exists, you can reach me out and put your comments below this video. Okay, the seasonal data created, seasonal precipitation. Now we only have 8 images, one image for each 3 months that shows the sum of the precipitation or sum of the daily precipitation. Let's do the visualization. So get the seasonal data and precipitation variable just like this, and plot it using this argument. X sets to longitude, one dimension, y equals to latitude, another dimension, and call when you want to plot multi-temporal data, the call must set to time. So, and the next one is robust equals to true, because we want to skip the actually outlier values and increase the contrast for the visualization. Call wrap shows how many images do you want to show for each row. For example, we have 8. I'm gonna actually show 4 images in each line or in each row, meaning that I will have 2 rows and 4 images per each. So, and the next one is color map equals to a spectral. So run the cell, and after a few moments you will have a multi-temporal plot that shows precipitation, seasonal precipitation variation, and you can compare the season. For example, the winter in 2020 compares to 21 actually experienced more precipitation values. And here the legend that shows the value of precipitation per pixel and for each season. So, and now you can compare the winter, spring, summer, and autumn for 2 years. And overall, as you can see, 2020 was actually a wet year compared to 2021, and we had more precipitation in this year. This could be one of the interesting result, appealing result for the users who are working on precipitation data monitoring and drought analysis. Okay, now in the next step, I'm gonna, for example, select one point in the region of interest and monitor the dry spells to see that how many dry spells do we have for these 2 years with different duration and different characteristic. Let's go to the code editor environment and find a region, select a point for your region of interest. For example, I'm gonna select a point from north of Iran, where actually this area is very wet and also experienced a heavy precipitation during a year. And now I'm gonna select a point, and then we have a longitude and latitude for the selected point. So now I'm gonna actually find that point in the dataset, in the multi-temporal data. Let's make a new variable as point equals to, from the daily dataset, select a longitude and latitude. The longitude equals to this value, the first one, and latitude equals to the second one, just like this. latitude and longitude selected, and we want to find the nearest value to this actually address. Let's run a point, and now we have a one value actually for this coordinate during the time. You can see still precipitation, but only for one region located in these coordinates. So now in the next step, I'm gonna make a column and make a data frame with two columns. The first one is the point value, PR value, or precipitation value for the point, and also the time value for the point as the next column here. For example, a new variable as PR created sets to point.precipitation because the variable name is precipitation dot values. If you print the PR, you can see the precipitation for that point with the array structure, just like this. And the next one is the time equals to, from the point, select another dimension or time. Then dot values gives you an array structure of existing time. Let's print the time, and you can see the array of times available for these 2 years. But these are array structure, and we must convert them into a data frame structure, because in the data frame we can organize our data very well and we can do further analysis easily. So to do this, to make a data frame, we need to import pandas as PD. Pandas is one of the well-established or well-known libraries in the Python programming language that provides numerous facilities related to data frame structure and processing related associated with. So a new variable now as data frame created sets to from pandas. Actually, I'm gonna make a data frame. So inside the curve bracket, the first column is time equals to time, and the second column is PR equals to PR. Let's run a data frame. Now we have a problem. The pandas as PD didn't run. So now it is run, and it is ran, and now the df is available. Let's print the data frame, and here you can see two columns, one time and one PR values available, that shows the precipitation for that point, daily precipitation based on millimeter for different dates available. Okay, now in the next step, as I'm going to find the actually the dry days with zero precipitation. In the first step, I need to make a new column. I want to add a new column to the existing data frame as dry equals to, from existing data frame, those actually cells or those values, those precipitations equal to zero, actually sets true for dry or set false if precipitation is greater than zero. So let's run and see what is changed in the data frame. Here all the actually PR zeros actually showing dry as true, and those of actually values PR values greater than zero showing false. And this is very helpful to discriminate the dry and wet days as two classes. In the next step, we need to make a category or make a group category for the dry, consecutive dry, and consecutive dry and wet days. So a new column will be added as group, because we want to make a category for consecutive dry and wet days. So make a parenthesis inside. So the if now actually we write like this: if df dry or dry day not equal to the next cell shows with df dry shift. For example, if you want to compare this cell with the next one, you can write like that. The df dry, for example, this one is not, this is negative, is not equal to df dry the next, this one. So the next line actually highlighted using the shift here. Now we are saying that let's compare each row with the next one and then calculate the sum of the values. It's a little bit complicated to understand. Actually, it's totally normal in the first step. You need to try to write it. So, but if you make a print from a data frame, you can see through this comparison and cumulative sum, actually, we make a single category for each classes. Those, for example, first we have 4 days, 4 dry days that actually shows true, and they have only one single value, that is number 1. Or if you have two situation in row, for example, 2 days with false group, then they will have a single value, 202. So like this. And this kind of grouping structure helping us to find the dry and wet spells easily and without any challenges. So for example, in the last part, this is the simplest structure that you can use to find the dry spells. If you actually think it's a little bit difficult, I'm highly suggesting you to write this code like me and compare the result for each step. Just you need to understand how actually this logic and comparison. You need to know the df.dry that shift, what means. Actually, that shift means one row after the current one. So with one shift, we are comparing each row with the next one. This is done using the shift. That is very important. So in the next step, a new variable as dry spell created. Dry spell equals to all the calculation is going to handle based on those of cells in which dry value is true. So that's why from existing data frame we need to select the dry cells first, and then we need to group them through the group based on group value or the values considered as their category. And then for each category we can do the aggregation. For example, we want to calculate the start date for each group. Start date, we say from date column shows the first. The next is end date. From date column shows the last one. And also the next one is duration. From date column shows the number of days or count. Or if you want to have the intensity, but as the intensity is 0, we consider it pixels with 0 precipitation. That's why the intensity will be 0. Just I'm saying how to do this. If your threshold is, for example, less than 1 millimeter. PR, now from PR column now gives me, for example, the sum of the precipitation. Okay, let's run the dry spell. Seems something is wrong. The date is not exist. Yes, as you can see here, we have time, not date. It was my fault, sorry. All the dates converted to time, just like this, and run a code. So the dry spell created result equal, but before the result, let's get a print from dry spell. So as you can see here, we have a start and end date with the duration. We need, for example, those of dry spells greater that their period is greater than 10 days. So we can do like this. Those dry spells in which the duration is greater than, for example, greater than 10 days. So if you run, then you can have a list that shows the dry spells in which the duration is greater than 10 days. For example, from June 19 to July 4, you can see we had 16 days in a row without any precipitation, or precipitation value was 0, or even sometimes it is extended to 50 days. That is too much for a wet region. And also these signals actually might be because of the climate change or the long-term drought condition happening in this area that need more studies to understand what's happening in this area. But if you want to get understanding about the dry spells and also prepare such kind of a query, the Google Earth Engine and Python programming language allowing us to do this analysis very easily. So now if you want to get export here, just make a new variable as result, copy and paste this. Now I'm gonna actually have a result as a CSV and out to the output. Here is dry spell.csv. Let's run, and in the left panel, after a few moments, you will have a dry spell, and you can download it here with the CSV format without any challenge. You can open it up into Excel software or any other software actually that's consistent with the CSV data. I hope you liked this tutorial as much as I did, and please share this tutorial with other people who are interested with Google Earth Engine and climate data analysis or environmental modeling. And please pay attention, please look at the other videos that could give you more insight about climate data, environmental data, and here we are addressing remote sensing solutions for environmental studies that could be really beneficial for all of the earth science users. Thank you for your attention.